In these problems, we're going to use the limit definition of the derivative to find the slope of the line tangent to the function at the given point. So our first function is a line. So if you think about this just in your head, a line, well, the tangent line to the line should be pretty much identical to it. But let's go ahead and walk through it and see if we get that answer. So if this is here, so f of c, or c is negative 2. So that tells me that f of c is negative 20 plus 4, which is negative 16. And f of c plus delta x is 10 times negative 2 plus delta x plus 4, which is negative 20 plus 10 delta x plus 4, which is negative 16 plus 10 delta x. So I have this piece and that piece. So we have to find this piece and that piece, and then we divide by delta x. So we take the limit as delta x approaches 0 of f of c plus delta x minus f of c over delta x, which is the limit as delta x approaches 0 of negative 16 plus 10 delta x minus negative 16 all over delta x, which equals the limit delta x approaches 0, so that's negative 16 plus 10 delta x plus 16 over delta x, which is the limit as delta x approaches 0 of 10 delta x over delta x, which is the limit as delta x approaches 0. Notice you end up writing the limit a lot. It's going to happen, so just get used to it, of 10. Now the limit here no longer depends on this. So remember, the limit of a constant is still just that constant. So that tells me that no matter what, the slope is 10. Which makes sense. You would expect that on a line, that tangent line will always have the same slope as the line. So in this case, these numbers match. It didn't matter that we were going to negative 2. We could have started by plugging in 0 or anything there, and that would have worked. But that's not true for this function. So this is a quadratic function. It's going to be a parabola. So where it strikes matters. So anyway, let's solve using this. We need to find f of c. So that's 3 1/5 squared minus 4 3 25ths minus 4. Well, that's 100 25ths, so we end up with negative 97 25ths. And f of c plus delta x is 3 1/5 plus delta x squared minus 4, which is 3 times 1/25 plus 2 fifths delta x plus delta x squared minus 4, which is 3 25ths plus 6 fifths delta x plus 3 delta x squared minus 4. So there's a lot of work here. And then we can simplify that to negative 97 25ths plus 6 fifths delta x plus 3 delta x squared. So there's a lot of work there, but now we can fill out the limit. So I'm going to do something which you're really not supposed to do, but for the sake of board work, let's go ahead and examine this quotient before we take the limit. So we're going to take that quotient and we're going to simplify it, and then we're going to add the limit. And that'll save us a little space. So we're going to say that, so you have this thing, negative 97/25 plus 6/5 delta x plus 3 delta x squared minus negative 97/25. So this term and that term are going to cancel. So now you have 6/5 delta x plus 3 delta x squared over delta x, which we're then going to factor. Bring a delta x out, so you have 6/5 plus 3 delta x over delta x. So the delta x's cancel. So that tells me that this is equal to that, at least from a limit standpoint. So then if I take the limit of this, it's the limit as delta x approaches 0 of 6/5 plus 3 delta x. And if you remember your properties of limits, since I have two things added together, I can take the limit of the first one, and that's a constant, so it doesn't matter, and the limit of the second one, well, as delta x goes to 0, so does 3 delta x. So that tells me that my answer is 6/5. Now what you'll find for this one is that c value matters a lot. Like at c equals 1, the value was 6. At c equals 2, the value is going to be 12.